Hello, I'm Kenny Coleman, a Senior Technical Marketing Manager at VMware, and in this video, we will look at the process for getting started using vSphere with Tanzu, using the Virtual Distributed Switch. And this is enabled using Tanzu Basic and Tanzu Standard licensing with Enterprise Plus. Alright, let's get started. There are a few prerequisites to installing and configuring vSphere with Tanzu, also known as workload management. First, to get the images used for running Kubernetes, we must subscribe to the official VMware content library. The subscription URL can be seen here, but is also available in the documentation. These signed images have all the components pre-configured that are required for automatically deploying and configuring Kubernetes clusters. Next is setting up HA Proxy in the content library. HA Proxy will function as a layer 4 load balancer for a few different components. It will front end the Kubernetes API server for the supervisor cluster, which is our management cluster running all of the cluster API components for creating Tanzu Kubernetes Grid clusters. This will also serve as a front end to the Kubernetes API server for the new Tanzu Kubernetes Grid clusters on the control plane. Lastly, it will also be used to create service type load balancer when needed by applications running inside Tanzu Kubernetes Grid clusters. To understand the complete setup, let's take a look at the network architecture. There are multiple configurations for HA Proxy, but this video and configuration will show how to use two networks with a default configuration. Two networks are needed for the management and the workload address spaces. Each needs its own static IP and gateway for the NICs on the HA Proxy VM, and we also need a range of IP addresses that will be allocated to the supervisor cluster, Tanzu Kubernetes Grid cluster virtual machines, and the load balancers. The caveat is to make sure that the networks are not on the same broadcast domain. So you can get wild with subnetting, or you can use two disparate networks on different VLANs to make it easy. Here's an example of how to allocate IP address space between the two networks. For instance, the management network will be on the 192.168.0/24 subnet. Within that IP address space, we're going to allocate IP addresses starting at 192.168.1.5 and up for the supervisor cluster management network. The workload network can get a little confusing, but this should help simplify it. An IP space has to be reserved for the load balancer usage. This will require getting a subnet or a range allocated. And this is where you can start playing with the IP address space to get a range that you would like. Then you can use the remaining space for the workload network IP addresses. HA Proxy is a layer 4 load balancer, so it's always possible to combine it with an ingress controller like Contour to use layer 7 load balancing and not use up all the IP addresses from the load balancer range. So here we have two different port groups on two different subnets and IP address spaces. When HA Proxy is deployed, it has two NICs, one on each network that gets configured with a static IP address. Next, the supervisor cluster is deployed. This Kubernetes cluster is responsible for managing other Tanzu Kubernetes Grid clusters, and each virtual machine in this cluster gets two NICs, one on each network, and the IP addresses are used from the allocated IP address ranges. For the management network, an additional floating IP is allocated, which becomes the Kubernetes API accessible IP address. The leader election process for the supervisor cluster will determine which VM gets the floating IP. The workload network is given a load balancer IP address from the reserved IP space, configured for load balancers or virtual IP addresses. This is the IP address that will be used for interacting with the supervisor cluster to deploy Tanzu Kubernetes Grid clusters. After authenticating to the supervisor cluster, a Tanzu Kubernetes Grid cluster can be deployed, and these get a single NIC that connect to the workload network. The Kubernetes control plane is deployed first, and this NIC will pull an IP address from the workload reserved IP space, but then once a control plane is ready, it will be front-ended by a load balancer for the Kubernetes API server requests. Then the Kubernetes worker nodes are deployed. Lastly, deployments and applications inside of Kubernetes can expose themselves using a service type of load balancer. Once that is invoked, a load balancer is created and allocated from HA Proxy. And now a user can access any one of these services by using the load balancer service of the HA Proxy virtual machine. Here's an example of the virtual distributed switch with two different port groups, one for the management and one for the workload. Going through the deployment is pretty straightforward. Once we get to the configuration screen, this is where we enter the two different networks for the management and workload. Next, the customization is where to add the appliance root password and then the corresponding static IP addresses for each NIC on the virtual machine. The load balancer section is where to enter the IP address range used for load balancers or virtual IP addresses for this HA proxy virtual machine. The data plane defaults to port 5556 and then enter a password for the admin password. After deployment, power on the HA proxy virtual machine. After the HA proxy virtual machine is ready, SSH into it using root and the password specified during the OVA creation. We will need the certificate authority, which can be found at etsy/haproxy/ca.crt. We'll come back to this later. Within vCenter, select Workload Management from the menu dropdown. If this is your first time accessing this screen, there will be a form to enter contact information to sign up for the trial, or a license key will also remove the screen. NSXT is not detected, so we will choose to use the vCenter server network and then select our compute cluster. The load balancer section is where we need to duplicate information that was configured on the HA proxy deployment. Provide any name, select HA proxy as the type. Then we need to enter the static IP address that was assigned to the management NIC along with the default port of 5556 and the username and password combo for the HA proxy service. The IP address range for the virtual servers is the same as the HA proxy load balancer IP range. Lastly, we must copy over the certificate authority from the HA proxy virtual machine. Moving into the management network, select the port group and the starting IP address to be used for the floating IP and the supervisor cluster virtual machines. With the workload management, leave the IP address for services untouched, unless this network interferes with an existing network in your environment. This network will be used for the container networking interface or the CNI inside of each Tanzu Kubernetes Grid cluster. Add a workload network by giving it any name. Select the port group and enter the IP address range that will be given to the virtual machines connecting to the workload network. Next, add the content library by choosing the VMware subscribed content library for Kubernetes images that we originally configured. Then, we deploy. The time this process takes will be dependent on your environment, but on average, will take somewhere around 20 minutes for the supervisor cluster to completely configure. After the supervisor control plane is up and running, there are a few other things to configure before completing the vSphere with Tanzu configuration. First is creating a tag that can be used for the storage within a vSphere namespace. This tag then needs to be assigned to a data store or multiple data stores. Next, within Workload Management, click on Create a Namespace and give it a name. Now, assign permissions. For ease of use, I'm going to use my administrator credentials to make sure I have edit access to this namespace. Lastly is assigning a storage tag and associated data stores to be used by the namespace. As a vSphere administrator, I can also enforce CPU, memory, and storage limits to this particular namespace. More on that in a later video. To access this cluster as a vSphere admin or as a DevOps persona, or anyone that needs to deploy applications to Kubernetes, download the kubecontrol and kubecontrol vSphere binaries from the supervisor cluster load balancer link. Put these binaries in your path to use them in your shell. From the shell, I can log into the supervisor cluster and change the context to the namespace that was created earlier. Here is an example of a Tanzu Kubernetes Grid cluster. This simplified specification shows the name of the cluster, the namespace where it will be deployed, the Kubernetes version to be used, along with the control plane and worker node count. The virtual machine class will dictate its size and resource reservation. And lastly, a storage class will be defined as the tag earlier where the virtual machines will be deployed and also used for persistent volumes within the Kubernetes cluster. Apply this configuration to the supervisor cluster and it will kick off a series of events using Cluster API to automatically build the Tanzu Kubernetes cluster. The control plane is created first, followed by the workers. In the shell, we can get a status of the cluster being deployed to view its progress and if it's ready to start accepting application deployments. After the cluster says it's ready, we must log into the Tanzu Kubernetes Grid cluster itself and change our context so we are interacting with it the same exact way we would interact with any other Kubernetes cluster. Viewing the list of everything on the cluster, including the pods, shows that everything is set up, including storage with CSI or the Container Storage Interface, and networking with CNI or the Container Networking Interface. Tanzu Kubernetes Grid clusters are inherently secure by default and only allow application deployments with proper privileges and role bindings. To get around this for demonstration purposes, a cluster role binding is applied that negates pod security privileges. Then we deploy an Nginx image, scale it up to 2 replicas, and apply a service type load balancer to it. Once the external IP is ready, we can access our deployed application externally from the cluster. We can also get an inside view of this by looking at the HA proxy configuration. We have 3 load balancers deployed. First is the Kubernetes API server for accessing the supervisor cluster on its workload network. Then there is the Kubernetes API server for the Tanzu Kubernetes Grid cluster control plane. And lastly, we have the IP address assigned to the service type load balancer from Nginx that was provisioned within the Tanzu Kubernetes Grid cluster, because we can see it's bound with port 80. Thank you for watching this video on how to deploy and configure vSphere with Tanzu using the virtual distributed switch as a part of Tanzu Basic and Tanzu Standard. Please refer to the documentation for all the latest material and updates.